Today we are in lesson 7.2 compound angles. We are going to prove what is called by the compound angles or addition formulas for sines, cosines and tangents. We start with what is sine of a plus b and what is cosines of a plus b in terms of the sines and cosines of these angles separately. We can prove by using this diagram. Here I have a right triangle OCD, and on top of that I have another right triangle OAC. The first triangles have an angle A down here, the second triangles have an angle B, and the second triangle also have a hypotenuse of 1. Before we start, let's just refresh your mind on the definitions of sines and cosines. The cosines of theta is defined as x over r, and sines of theta is y over r. I just solved for these two equations for x and y. So for x, I will have r multiplied with cos theta, and for y, I will have r multiplied with sin theta. Therefore, I can figure out that y is equivalent to r sin theta and x is equivalent to r cos theta. This is useful if we know the angles and the hypotenuse, then this gives us the other two sides of the triangles. So let's start. Look at the triangles OAC. We have the sin B equivalent to AC over 1. We solve for AC. We will have sin of B multiplied with 1. So you have the sin of B. So your AC is sin of B. And for cosine of B equivalent to BC over 1. So we solve for your BC is equivalent to cosine of B times 1. So you have the cosine of B. So your BC here is cosine of B. Now we look at the triangle OCD. We have the sine of A equivalent to CD over cosine of B. So we solve for your CD. So you have the CD as sine of A multiplied with cosine of B. And finally, we have the cosine of A equivalent to OD over cosine of B. So your OD will be cosine of A multiplied with cosine of B. So your OD is cosine of A multiplied with cosine of B. We have to make this diagram a little bit more complicated. I'm going to draw a line from the point A, reach the bottom here, and add a right angle at the point E. And then I draw another line here, which meets the line at a right angle at the point F and intersect at this vertex point C. We notice that the line FC is parallel to the line OD. Therefore, we will have an alternate interior angles here. I label it as A, and this full angle is right triangles. Therefore, the angle here will be 90 degrees minus A. And we will notice that the angle here is also A. To find the size of AF and FC, we apply the basic definitions of cosines and sines. So look at the triangles AFC. We will have the cosines of A equivalent to AF over sines of B. We solve for AF, so you will have the AF as sines of B cosines of A. So we apply the same process for sines A equivalent to FC over sines B. So we solve for FC, so we will have FC as sines B multiplied with sines A. So your FC is sines B multiplied with sines A. Okay, well, we are actually just about ready to give our proof now. Look at the triangles OAE. Here is the angle of A plus B. So we will have the sines of A plus B equivalent to AE over 1. Since your AE equivalent to AF plus FE, so we will have sines of B cosines of A plus sines of A multiplied with cosines of B. We just rearrange the orders of multiplications, so we have proved our first formulas of sines of A plus B. We proceed to cosines of A plus B, so we will have OE over 1. Since we know that your OE will be OD minus ED, so you will have the cosines of A multiplied with cosines of B minus with sines of B multiplied with sines of A. We do the same process. We rearrange the orders of the multiplications and you will have the additions formulas for cosines of A plus B. When the angle of B equivalent to minus B, the additions formulas for sines will become sines of A plus minus B equivalent to sines A multiplied with cosines of minus B plus sines of minus B multiplied with cosines of A. So we just have to take note of this. The cosines of minus B is equivalent to cosines of B, and the sines of minus B equivalent to minus sines B. So take note of positive and negative here. So therefore, we will have the addition formulas of sines of A minus B is equivalent to sines of A multiplied with cosines of B minus with sines of B multiplied with cosines of A. So similar we do for cosines of A plus minus B here. So we will have the cosines of A cosines of minus B minus with cosines of A sines of minus B. So we have to take note of this. So this will be equivalent to cosines of B, and this one will be equivalent to minus sines of B. So be careful of minus and minus here. So we will have the addition formulas for cosines of A minus B is equivalent to cosines of A cosines of B plus the sines of A multiplied with sines of B. To prove the addition formulas of tangents, we start from the definitions of tangents in terms of sines over cosines. So we will have tangents of A plus B is equivalent to sines of A plus B divided by cosines of A plus B. We apply the addition formula for sines and cosines, and we divide both numerator and denominators with cosines of A multiplied with cosines of B as this, and we do simplifications. This we will get tangents A, and for this cos A, we simplify, we will have the, for this one, we will have the tangent B here, so this one we may simplify, and for this we will have the tangent A, and for this side you will have the tangent B. So therefore we have the tangent A plus tangent B divided by 1 minus tangent A tangent B. When the angle B equal to minus B, so we have the tangents of A plus minus B equivalent to sine of A plus minus B divided by cos of A plus minus B. We apply the addition formulas for sines and cosines, and we need to take note of cos of minus B equivalent to cos B, and this equivalent to cos B. Sines of minus B equivalent to negative sines B. Sines of minus B equal to negative sines B. And if we divide both numerator and denominators with cos A, cos B, we simplify. So here you will get tangent A. So this one you will get tangent B. This one you simplify. Here tangent A, and here is tangent B. Therefore, we will have the tangents of A minus B equivalent to tangent A minus tangent B divided by 1 plus tangent A multiplied with tangent B. Finally, we have just proven all the compound angles or addition formulas for sines, cosines, and tangents. Hope you enjoyed this video.